Ramanujan for G is now available on the Google Play Store. Try it out for free.
Hi students, so we are back. So this is a continuation of the class 11 students. This is not for the class 12 students. Class 12 students is tomorrow, and tomorrow I have an early lecture. So here is the thing. Um, for the class 11 students, right now we are going through mechanics, right? So in mechanics, you must learn simple things well. What do we mean by that? There are two to three ideas in mechanics that you must know. The first idea is the application. Firstly, let's go to the slideshow. Okay. So first, you must understand how to use our platforms. Okay. So before I go into pseudo forces and problems dealing with Newton's laws, right? I want to explain how you should study. Okay. See the Jnanamarga study methodology, right? What should you do? First thing you do is you download the app. Second thing you do, you try to, if you are buying our tablet platform, then everything comes for you. But if you're not buying the tablet platform, I suggest uh, uh, strongly, particularly if you are a NEET or JEE student, I suggest strongly that you buy Concepts of Physics by Professor S. C. Verma, Padma Shri. This year they are awarded this year. So very much dedicated teacher. And so you get his Concepts of Physics Volume 1 for this year, Volume 2 for next year. Some parts are a little bit changed, but you get both if you want. Good students should aim for both. Maybe they'll give you a discount. Okay. So otherwise, you can get it from somewhere. So in our model, what happens is you download the app, then the NCRT textbook comes. So as you read the NCRT textbook, you should be watching the IIT PAL videos. And along with that, you can also look at the corresponding chapter in Concepts of Physics. Okay. So that is how you go about it. Now, the most important initial thing that students at this level should be doing is they should be learning sufficient calculus and vectors. So once you've done that, then you're ready for this chapter that we are discussing, which is Newton's laws and how to apply Newton's laws. Newton's laws are an extension of the first thing that Newton did, which was calculus. Newton's laws are an extension of the other work that was done, which is vectors. Now, when you look at Newton's laws, although they are spoken in English, right? He is talking in vectors. He is talking in vectors. If you miss the vectors, if you miss the calculus, he is talking in calculus. you know, it is many things. There is a language associated with a subject. The words associated with a subject have a different meaning compared to the words that you use in natural language, in daily language. That's the first thing you learn in when you start studying any science subject. They have that added meaning. The word reaction means something very different in physics and very different in chemistry. I'm sure by now you understand that, right? What is a reaction? What is a reaction? If you ask the physics teacher, he will teach you something else. What is a reaction? The chemistry teacher, tomorrow you go ask Dr. Tiwari, what is a reaction? He will give you a different explanation. You ask me as a physics teacher, what is a reaction? I will give you a different reason. Okay. So that's why what you should do is read the textbook, understand the precise meaning of the words as they appear in context, watch the video, watch the slides. Once you've done these two, then you have built a understanding of these words, they have a deeper meaning in the context in which they are used. Then you read it well, and then you are in a position to apply the things that you already know. Calculus you have learned, vectors you have learned. So that is the first thing. We have videos on calculus and vectors. I will restart, maybe I will do one or two classes after this in that. Okay. But today, but you can always look at the existing videos that we do have. It is there in our playlist. It is there in our app. So these are very, very critical to the success, to your success. So now, students who are going to be doctors, or who are planning to be doctors, because these exams are very difficult, I cannot give you a guarantee, and neither can you or anybody else. Download Sushruta. Sushruta for NEET. Sushruta helps you prepare for NEET. Okay? People who do well in NEET, they have so many other options also. But if you want to be a doctor, you must be studying hard. You must be studying hard. Now is the time to study hard. So, go to Play Store, download com.sushruta, and then you proceed. When you are studying physics, you go to Physics1. If you are a class 11 student, if class 12, go to Physics 2. If you are a class 11 student who has completed Physics 1 fully, he has now mastered the material, you can go to Physics 2. You see, this is the way it happens. Students learn, they move forward. Okay, so this is Sushruta for NEET. Okay, so Sushruta for NEET comes in two forms. One is our cell phone version, which and then there's a tablet version. Tablet version is more expensive. Cell phone version is lower priced, and when provided in bulk to schools, it is cheaper, or through a tutorial institution, cheaper. Okay, so now our programs today come with everything, almost everything, right? So if you get the Sushruta for NEET, you will get the NCERT textbooks. But if you buy the tablet version, you will also get H.C. Verma as an ebook, But even the cell phone app, if you buy the paper book, right, you can then use the link there to go to where in H.C. Verma to look. Okay, so my advice to all students is, you have the full slide deck, use the slide deck, use the thing, use the lectures, and keep going forward. Jnana group chat is there, I don't know how many of you are going to be using that, but that also is there, and we are going to be building all that. Now, we have the IIT PAL videos linked with every chapter. Watch the IIT PAL videos. Now, when you still have time, you should be doing this. You should be building knowledge base then. The second app we have is for the JEE students. It is called Ramanujan. Both Sushruta and Ramanujan are trademarks. Now, Ramanujan for JEE also comes with the same solutions. For maths, we prefer Tivani. Okay, so I will show you Tivani. Okay, so this is Tivani. Now, Tivani is an excellent book for JEE mains. Okay, so you should buy Tivani, and you should go about it if you are preparing for JEE. Okay, this is our what you see here is not our cell phone solution. This is our tablet solution. It also comes with H.C. Verma as an ebook. Tivani we also provide. If you buy, right, it will be sent by Amazon to you. Otherwise, you can buy some of these apps. Okay, so what is different now with the newest apps is that it has assessment integrated. When you study a particular chapter, next do the questions. Today I am going to be doing some questions. Okay, so as I explained, the laws of Newton come with wording that is very in context and specific to the subject you are learning. First law: object remains in a state of rest or in uniform motion in a straight line unless compelled to change that state by an applied force. Okay, so now the tendency of an object to remain in a state of rest or uniform motion is called inertia. So what is inertia? You don't observe inertia, you only half observe it. Okay, I'll show you why. Okay, so see, now this object is in a state of rest. It stays in a state of rest, right? So that is one aspect of inertia. The other aspect of inertia is when an object is moving. Okay. Now, in the normal physical world, an object that moves does not keep moving. There are reasons, many reasons that cause it to slow down. Most common is various types of friction: air friction, ground friction, etc., etc., etc. Okay. Now, this the ball in Shivaji Park. I always tell the story, right? This Sunil Gavaskar, cricketer, commentator. When he became a commentator, he would speak of Shivaji Park because the Australians would ask about the Shivaji Park. You know, now in Shivaji Park, he would say that if you hit the ball, it would go rolling, 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 because almost as though there is no rolling friction. You know, but there is rolling friction. You know, but typically when balls roll much further, it is because there is no force to counteract them, or there is a very minimal force to counteract them. In the normal world, there is always some force. Okay. But in the ideal world of Newton's laws, if there is no force, something in uniform motion, that is something with a velocity with no force acting on it, will keep moving with that same velocity forever. I stopped to ensure that you felt the impact of that forever. Okay. Now, so that is the law of inertia. You have to understand Newton's first law. Then you have to understand this idea of the associated term inertial reference frame. What is a reference frame? Reference frame is an observer. Okay. This observer is a amazing word. We are all observers of all that's happening around us. Okay. Now, in the context of Newton, we are talking of someone who is observing, say, the object of, that is the topic of the observation. Okay. The object that is the topic of the observation is being observed by the observer. Now, if the observer is not moving, the observer is not moving, then the observer is in an inertial reference frame. Or if the observer is moving at a constant velocity, even then the observer is in an inertial reference frame. When is he in a non-inertial reference frame? When he is accelerating or decelerating, or he is moving, Now, these are all, when does that happen? According to Newton's second law, it happens when there is a net force on the observer. Okay? So now we have talked about the observer, right? Let us come back to what we were talking about. When Newton talks about Newton's first law, he is talking about the observed. The object in Newton's first law is the observed. Okay, so this is the most important idea. But who is to say this object is in a state of rest? The observer. Who is to say it is moving in uniform motion? The observer. Okay, so if the observer is inertial, then he can say you are inertial, right? If the judge himself is a criminal, how can the judge say that somebody else is a criminal, right? The judge has to be innocent, right? Then only the judge can say the criminal, this person is not a criminal, right? So think of it, all these are just what do you say, metaphors or examples, right? These are all to teach you. Don't take that and get caught in all that, right? What you need to understand is this idea being taught in by Newton's first law. Newton's first law has inbuilt into this idea of the inertial reference frame, and this is a very central idea in Newton's first law. Now, Newton's second law, in an inertial reference frame, the force equals ma, that happens in an inertial reference frame. If it is not an inertial reference frame, then we will talk about the pseudoforce and all that. Okay, but in an inertial reference frame, F equals ma. The net force leads to a rate of change of momentum. Now, momentum is what? M times v, right? And therefore, rate of change of momentum is what? What does that mean? to Newton, who also invented calculus, rate of change is what? D by dt. The rate of change of position is velocity. The rate of change of velocity is acceleration. The rate of change of momentum is, therefore, he said rate of change of momentum is proportional to the force. Then they said, okay, doesn't matter. Let's drop the proportionality. So the rate of change of momentum is the force. dp by dt equals f, right? Newton's second law. Then finally, Newton's third law. That's when you have action reaction, right? Every action has an equal opposite reaction, right? What does that mean? Every action has an equal opposite reaction, right? See, when they state such a thing in the passive voice, right? Every action has an equal opposite reaction. Who is the actor, right? Who is he acting on? Who is the reactor? Who is the reactor acting on, right? So if there is an actor A and a acted upon B, if A applies a force on B, B applies a force on A. You see these boys always in the playground fighting, right? Or girls, right? So pushing each other, pushing, fighting, right? So A applies a force on B, B applies a force on A, action, reaction. But what can be said? If A applies a force on B, right? FA, this is FB, FB is minus FA. That is Newton's third law. But remember that an action and its reaction act on different bodies. A applies a force on B. Who is experiencing the force? B. B applies a force on A. Who's experiencing the force? A. These are two different bodies which are experiencing. One experiences the action, the other experiences the reaction. Let me say it again. One experiences the action, the other experiences the reaction. Okay, so that is how this works. Okay, so I restated it. We looked at this question last week, right? So what we are again going into is this free body diagram. What is this free body diagram, right? Free body diagrams are drawn to reflect a particular body, like in this case, this knot P, right? It has a T2, T1, T3, right? This mass, right? M, it has a mg, it has a T3. Okay, strings with no mass have the same tension all over. Okay, so if you take this T3, if you take the string itself, if you draw its free body diagram, there is one T being applied by the P and another T being applied by the M. Both are T3, right? So T3 up, T3 down, therefore the net, so P is at rest. Okay, P is at rest because there are two counteracting forces by two different bodies acting on P. Now, because the mass is applying a T3, a weight is applying a force of T3 on the thread is also applying a force of T3 on the mass, according to Newton's third law. So now when you draw the forces that are acting on the mass, there is the thread which is applying T3, then there is the earth which is applying a gravitational force mg, and the mass is at rest. Therefore, and one is up, the other is down. Therefore, when you look at forces in the vertical direction, T3 equals mg, right? So, and now when you look at the forces that act, remember that this equation SA equals minus FB, notice the S. It is a vector equation. So if you componentize, you actually end up with two equations. So that is the most important idea here. T3 equals T1 plus T2. but it's a vector equation. Okay, T3 equals T1 plus T2, vector equation. Therefore, now we componentize into two other equations. T3 equals T1 sine alpha plus T2 sine alpha 1 plus T2 sine alpha 2, right? And then T1 cos T2 cos alpha 2 equals T1 cos alpha 1. Okay, so now using these three equations, you have three equations, three unknowns. What are the three unknowns? T1, T2, and T3 is the magnitude of the three vectors. We know the direction of the vectors, right? So yeah, the magnitudes that are not known, and we solve for the three unknowns, T1, T2, and T3. We have three equations, three unknowns. You solve and you get an answer. Okay. So when there's more than one body involved, right, you draw the free body diagram of each body separately, applies Newton's second law, right? But keep in mind Newton's first law, keep in mind Newton's third law, and then you draw all the free body diagrams, and then voila, you have enough equations and enough unknowns to solve, right? That is the most important idea I want you to walk away with. There are certain circumstances in which you need a little more information. We will come to that in the fourth chapter. Okay, but right now there are enough equations. Most questions that you have enough equations, enough unknowns. So now here there is a body which is being pulled with tension T. There is friction, there is everything, and then we find out the net equation sigma F equals ma, right? We draw all the equations on this body. There is mg, which is the force of gravity on the body. There is N, which is the normal force, which is applied by the platform on which it rests, like the floor on which it rests, right? And that applies a N force of N on the body. The other force on the body in this direction is gravity, right, which is made by the Earth. Two different forces, unrelated to each other. They're not an action and reaction pair. Okay, then there is because it is being pulled in this direction by T, then finally because it's being pulled, the ground resists, and that leads to friction, right? And so you have sigma net F equals ma, and therefore you have to then solve. Now if you assume that it is going in the horizontal direction, then you can solve for A. He's saying kinematics A equals AI, right? So you have to do that. Okay, so why I went over this in great detail is so that you understand all these things. Okay, so I'm not going to go into the details of all, because I went through all this last week. Today I'm going to do some other problems, right? So we discussed variable mass systems last time. We discussed the various forces. We discussed static friction, dynamic friction, etc. Right? Static friction happens when there is something is at rest, in which case you know the acceleration but you don't know the friction, right? Then kinetic friction, you know the friction but you calculate the acceleration. We all discussed all this last time, right? Problems related to friction, right? Find the value of F, find the value of N, and correspondingly, first you find out if it is static or dynamic. Typically, they will tell you in the question. Sometimes they'll tell you, they'll not tell you. They'll tell you the mu k, they'll tell you the mu s, they'll expect you to find. Typically, mu s is greater than mu k. If your assumption is correct, the friction is static, then you solve for what? The friction. If your assumption is that fails, then you have to assume it's kinetic. Then the friction is known. It is mu times n. All right. So here is this question. We already looked at this question, but let us look at it again, because we want to draw the free body diagram here. Body of mass 10 kg is kept on a rough inclined plane shown in the figure. Force of 3 newtons applied on the block, right? Coefficient of static friction 0.6. What minimum force should be applied such that the block does not move downward, right? So the tendency of the block is to move downward, right? So now what is the tendency of the friction? It is to oppose it. So the static friction should be upwards. That's what they are saying. Once you realize that, your problem is solved, right? So, so you're trying to give a minimum force, right? If you didn't give that minimum force, what will happen? It will tend to slide downwards. But you're giving that minimum force. Some of help you get from friction, right? Friction is acting along with the force, the same direction of the force. So now you have mg, you have n, you have 3, you have p, and you have maximum static friction. When do you have maximum static friction? Just 0.6 times n. So now what is n, right? N is the only forces in this direction are what? So when typically in most inclined plane problems, as a rule, you componentize along the plane and normal to the plane. Okay. Now normal to the plane, there is what? N and mg cos 45. N equals mg cos 45. Okay. Now 3 Newton plus mg sine 45 equals mg sine 45 is what? The component of the gravitational force along the plane. 3 plus mg sine 45 equals p plus mu n. Okay, p plus mu n. Mu n is what? N is what? mg sine 45. So 0.6 times mu times mg sine 45, right? So plus p will equal 3 plus mg cos 45. So now using that equation, you solve and you end up with p, 32 newtons. So why is this taught? This is taught so that you understand how to solve inclined plane problems. Okay. When my daughter was in the 5th, 4th grade or something like that, they asked her to make an inclined plane. Why did they ask her to make an inclined plane? They wanted her to make some physics experiment, and she chose to make an inclined plane. Okay, and to explain this idea of friction. So now that you understand this idea of friction, right? You then learn about friction. Now here is this. Now we then introduce this idea of the pseudo force. Now, when the observer is non-inertial, right? The observer is moving with an A, right? So instead of, and let's say you are going in a train, right? 450 from Paddington is a book written by Azad, right? So you're going in a train, and on the other side you see something. Let's say the train is accelerating, then you see something happening in the other train, right? Now, if your train is accelerating and you want to convert what you are seeing into an inertial experiment, then what you have to do is you have to put a minus a, minus a, minus a, minus a, minus a on every object on the other side. Minus a, minus a, minus a, minus a on every object on the other side. And we call that D'Alembert's principle, Coriolis force, etc., etc., etc. Right? So Coriolis force is the name given when you have centrifugal force, etc., when you move in a circular path. Okay. Anyway, but the idea is that because you are moving like this, right, with an acceleration, right, you make the other side have a negative A as you see it. So if I see it, then if I make the other side have a negative A, then what happens? Then I'm looking at it from a inertial reference frame. So please understand that principle. You put it in the other way, right? and then you solve all these problems. So that is why we brought this problem. Frame S prime is moving at A with respect to inertia. Let's say you're sitting in a accelerating truck. Now, when you sit in an accelerating truck and you have a pendulum, the pendulum will move to an angle. It will be like this. It will not, to you, it will look like it is stationary, but it will be at an angle like this. Okay. Why is that? That is this. So, how do you then measure it? You put a minus A, right? So, you put another force. It is called a D'Alembert force, minus MA naught. So, you have T, MA naught, MG, you solve. But actually, what is happening to the pendulum? It is accelerating because the truck is accelerating. To you, it appears like it's at rest because you're sitting inside the truck. But the truck is accelerating, the pendulum is at an angle. So that is how you solve this, use this D'Alembert's force. And then we looked at a problem involving this D'Alembert, right? So right? So we looked at this example for pseudoforce. Why are we teaching these things in such detail, right? So that you understand the detail, right? So now then we looked at a particle in a curved path. See, when a particle moves in a circle, there's only one force. It is a radial force. Uniform circular motion, there is only one force. There is a force towards the center all the time. It is a radial force. Okay. So uniform circular motion, what is the thing? There is only one force, it is only a radial force. Now if you go faster and faster and faster and faster, we say that there is also a tangential component. So there is also a tangential force. So there are two forces, two components to the acceleration. There may be only one force, but there will be two components to the acceleration when it is going faster and faster and faster and faster. Okay, in a circle, right? So like sometimes you see these motorcycles in that, like a cylinder, they'll go like this, like that, like this, right? So that case, what is happening is that it has one radial component and the tangential. Okay. And in uniform circular motion, the body is moving at constant speed. There is no tangential component. There is only a radial component, and the value of the radial component is v square by r, right? V is equal to the acceleration is v square by r, right? So the acceleration has only one, right? And that is what? Omega cross v, right? Acceleration omega cross v, right? So v equals omega cross r, right? And acceleration is omega cross v. So you end up with omega cross r. Okay, so you end up with omega square by r, omega square r. Okay, so you end up with omega square r, and v equals r omega, therefore v square by r. Okay, so keep these formulas in mind. I tell it to you, but I tell it to you so you remember. For centripetal force, m omega square r or mv square by r, very critical, uniform circular motion. Okay, then all the formulas associated with time period and frequency. Time period equals t, frequency equals 1 by t, omega equals 2 pi by t, right? Or 2 pi f. A is equal to omega square r, etc. Alpha equals d omega by dt. It is the rate at which something is spinning, is the angular acceleration, d omega by dt. All right. So two components, centripetal and tangential. Two components. So remember, r alpha et plus omega square r en. En is the radial, et is the tangential, and alpha is the tangential angular acceleration. When they say angular acceleration, they naturally mean tangential. Okay, and it is what is angular acceleration? It is the rate of change of angular velocity. Okay, so note all these components. and be very good with them because we'll be dealing with them very soon. Okay, so V equals omega cross R, etc. Right? So, and therefore, with why are we continuing to emphasize these things so that you understand these things? Now, having explained all this, these questions I went with last time. So today I'm going to do some other questions. Okay, so this question is a very straightforward question. Notice 2004 is a JEE question. Two masses M1 and M2 are tied to a string, are hanging over a light frictionless pulley. They have to say all that. Light and frictionless are very important. Okay, tied to a string, light, right? What is the acceleration of the mass when left free to move? So now I am going to escape and I am going to solve this problem. You know why? So that you understand. So now you take this T1 mg, right? So now which is going to go down? M1 is going to go down, right? So M1 is going to go down. So M1g minus T1 or minus T. First thing is, because it's, the pulley is light, the two tensions will be equal, right? So that you must keep in mind. Okay, M1g minus T equals M1a. Okay. Now I'm going to write the other equation. T minus M2g equals M2a. Okay. So now I'm going to eliminate the unknown T, right? So now when I eliminate the unknown, how do you eliminate the unknown? Just add the two equations, right? So M1 minus M2g equals M1 plus M2a, right? A equals M1 minus M2g divided by M1 plus M2. There you go. Okay. So now, having written this equation, 5 minus 4.8 is 0.2 times 10. Always he is putting 9.8, but okay, 9.8. Maybe there's some clever thing about 9.8 times 5 plus 9 plus 4.8. There is something clever here, right? Equals 0.2 times 9.8 divided by 9.8, right? All right. Very simple. M1 minus M2 divided by M1 plus M2 times G, 0.2. All right. So with that, we take a look at this question, right? Coefficient of static friction between the block and the plane is 0.8. The frictional force, a block rests on an inclined plane. So again, you have to draw the free body diagram, right? What are all the forces on this block? N mg, this is 30 degrees, right? N mg and F, right? It rests and it is F, right? So now let us draw the forces perpendicular, right? Perpendicular to the plane. Right? Perpendicular to the plane, there is mg cos 30, right? Mg cos 30 equals N. Now, along the plane, mg sine 30, the force, the component of mg along the plane, mg sine 30, right? So now we are putting forces perpendicular. right? So now mg sine 30, right, equals 0. Is the frictional force on the block is one. Is at rest. Frictional force on the block is mg sine 30 equals f, right? F is what? 10, right? So now he's asking you, it's a trick question. You see, the first equation doesn't get you anything. If you use this 0.8, it is just a wasteful information, right? So now, if g is 10, right, sine 30 is half, right? M times 10 times 0.5 equals 10, right? So m equals 2. Okay. So what does this tell you? This tells you that they can easily trick you with these questions, right? So what should you not do, right? It is the coefficient of static friction is giving, and that's actually a waste, right? What you do need is only one equation, which is the force along the plane. Force perpendicular is irrelevant. All right. So with that, so when you solve these problems, the most important idea is to use these things that I taught you before well. Okay. And if you do use these ideas well, then you will succeed in a very, very big way with mechanics. Mechanics has only a few laws, but you must understand them very well. That's why we reteach it the second class today. Okay. So now this problem I'm not going to solve. I'm going to discuss it and make you think about it and solve it, because this is a inclined plane and there is some acceleration. Whenever the inclined plane is accelerating, maybe you need to use the pseudo force. Okay. So now a block is kept on a frictionless inclined surface with an angle of inclination alpha. So this is alpha, right? The incline is given an acceleration to keep the block stationary, right? So now, so the inclined plane is moving. The block is stationary, right? So now what do you do? Now you apply a pseudo force on the block, right? MA in this direction, right? So now MA, MG, and N keep it stationary. It is seemingly stationary, right? It's really not stationary, but it is stationary with respect to the inclined plane. So MA, right? MA in this direction, right? N and mg will keep it stationary. Okay, so now ma sine mg sine alpha equals ma cos alpha. Okay, the m's will cancel. Okay, so that's, if you look at, let me look at how to solve this. Okay, I hope you can see my screen, right? So now, okay, I'm going to solve it, right? So MA, so sine alpha equals mg cos, or the other way, mg, right, mg sine alpha equals ma cos alpha. So now let me change this to symbol. And how did we arrive at this? We arrived at it by applying a pseudo force. Okay? So there are certain problems where learning to use pseudo forces makes them a little bit simpler. And if you're not careful, okay, not careful, you will easily go wrong. Okay. And so now A is what? Now having written this, let me switch back to Calibri, right? A equals, what is A? A equals G tan alpha. You see? Very simple. All right? G tan alpha. So what does this teach you? Right? The ends cancel, right? So you just had to apply forces along the plane and then you arrived at this easy answer. Okay. So I would have preferred if students, if were able to solve this, right? So now let's look at this one. Okay. A smooth block is released at rest on a 45-degree incline, then it slides a distance d. Time taken to slide is n times as much to slide on a rough inclined plane than on a smooth inclined plane. Coefficient of friction is so now they want you to understand what happens in a rough inclined plane, what happens in a smooth inclined plane. In a rough inclined plane also there is motion, right? Rough inclined plane also you can solve, right? mu k, right? So now what they want you to do, they want you to draw two sets of free body diagrams, okay? And using the two sets of free body diagrams, solve for time, okay? So they are asking you to be adept at drawing free body diagrams, are asking you to be adept about S is equal to ut plus half at square, and then build this clever relationship. Okay, so I'm not going to do this problem. I'm going to leave it to you as an exercise. So take the problem and try to solve it. A smooth block is released at rest at an angle, 45-degree incline, then slides. I want you to sweat on this one. Okay, so draw a free body diagram. One, smooth inclined plane. Draw the free body diagram. Two, rough inclined plane, right? Then compare. There will be a difference in the force. There will be a difference in the acceleration. In which direction? Along the incline. In one case, there is also friction. The other case, there is no friction. When there is no friction, what is the acceleration down the plane? It is just g sine 45, right? Now, when there is friction, there is an added factor. You must draw the free body diagram, then only you'll understand the added factor. I will come up with the answer for you next class, but I want you to sweat it out and try this. This is a sweet problem, but again, it teaches you the details of all these inclined plane problems. The pulley problem, the inclined plane problem, and these, all these problems are the core of mechanics. Then you add in the calculus, add in the vectors. With these things, you can really cash in on your mechanics. So I always advise people who are JE students to be very good at this. Even the NEET students, this is something that you can really learn well, because if you learn this well, everything else, it repeats again. Electrostatics, there is force. Okay, this force and this vectors and everything, they keep coming and asking questions of you all the time. When you learn about force, when you learn about angular momentum, atomic physics also involves the force and angular momentum. Okay, when you understand these concepts well, they build and build and build, and after some time you will be in very good shape. Okay, so but then it is good to understand all these ideas first at the basic level, then at the more complicated level, then build, get adept at solving these problems. That's what I'm trying to teach you here. Okay, so this is the second round of class 11 physics with the aim of building expertise and doing better at solving these MCQs. Okay? Now, you should be looking at the solved problems in HC Verma, and you should be looking at these kinds of questions. I spent a little more time with these because for some students this is difficult. For others, this is not at all difficult. I want you to understand that, but you must be that student for whom it is not at all difficult. That's what I want for you. So please take your time, solve this problem. A smooth block is released at rest on a 45-degree inclined plane. Once one is one version of the inclined plane is rough, the other version of the inclined plane is smooth, right? So calculate the coefficient of friction, mu k, right? So we will look at this. We start the next class with this, but then I'm going to move on. I'm going to do a little more with circular motion next time. But before I transition, I'll do a little bit with, maybe projectiles, or with, I'll do a little bit with, also with collisions, projectiles, and then finally circular motion. I want people to, get the details of these things slowly, right? But then, at the root of it all is Mr. Newton, his three laws. They come again and again in mechanics, and then they have repercussions across the into electrostatics, etc. You always deal with Newton, okay, and you always deal with vectors. You always deal with calculus. You always deal with these ideas as you study physics. But get the app and keep practicing questions. That I'm going to stop today. I'm going to meet you all again next week. If it's Saturday morning, India time, IST, you're with me studying class 11 physics. Sunday morning, you're with me studying class 12. All right. So with that, I stop.